Booyah. How's it going, everybody? So I've done this once before, early on when I came on here, and yeah, some of this stuff. If you, I think we've got a bunch of people that are actually like fairly competent unit testers, right? I mean, for some jobs, it's like they say, oh yeah, make sure to unit test, but they don't. They like. There's no instruction. There's no there's no training. There's just not a lot around it. I've been definitely at companies where it's been like that. So some of this may be new to you. Some of it may not. Some of it's probably going to be controversial. Maybe, but maybe not. So I try to distill this down into just what I think is some of the most important aspects of unit testing. And so we'll see. Should go pretty quick, and then we can talk about stuff right after. Okay, so obviously unit testing's hard. It's harder than writing production code a lot of times. It's like trying to do that thing. It's going to be a lot easier than trying to sit and think about how you're going to test it. And there's a lot of companies doing automated test strategies that just fail, right? For any number of reasons, but a lot of it is because I think that unit testing is a skill that you learn. It's like a learned thing. You learn to develop without learning to unit test, but to unit test and have it be an effective tool for you, it's really an acquired skill. It's like another thing. So just because there are a lot of assumptions, I think that you bring on a developer, and it's like, oh yeah, just make sure you write some unit tests. Oh yeah, I'll write those things that you just said. But there's a lot of things in unit testing that I think seem intuitive, but work against you in the long run. And so some of these ideas that I'll talk about for some people that haven't heard them, I think may not sound intuitive, but end up being more practical ways to do it. And some of it's just sort of rotating your perspective on how you think about them. So how much unit testing should we do? Should we do enough so that we meet some coverage metric? Should we only, I've actually heard somebody say, well, if a piece of code's complicated enough, then I'll make sure to put in some unit tests in an interview. And they're not working here, unfortunately. Some people, probably not a lot of people would say this, but I think a lot of people think it, that haven't been able to use it well as a tool, and that's that a lot of times it slows down your project. You'll spend 80% of your time writing unit tests, and 20% of your time writing actual code that does something. And that's a waste of time. A lot of times you'll see projects start up where they have they're very ambitious about doing it the right way, and so they do unit testing up front and spend a lot of time, then they try to change it later, and it's really hard, and then they're out the window, and just those tests that never run anymore. But a lot of companies assume that people just know how to do it. So always, I don't think that's always appropriate to unit test. Overly complex, that should probably be refactored. Never unit tests. Well, I think if you're able to use it as a tool, most people that I know that have been able to use it as a tool can't do it without it. I mean, it's a really invaluable tool for a lot of good reasons. So the goal of unit testing, which I think this is one of those not intuitive things. I mean, it has tests in the name, but it's really not to test, right? Good tests will take sort of a blind approach, and they'll try to explore all the different avenues and try not to think about what the internals of something are. They'll try to think about how can I do something that's going to break this thing, right? And that's actually not the best way to do unit testing, and that's because your unit tests, I heard somebody say this once, is you think of it as just a way of measuring your application. It's a bunch of levels and dials that'll say sort of give you a status of your application, right? Good unit tests, when you change something, will only pop up little failures here and there where it says that something was doing something that it is no longer doing, right? And to be able to use it as like a measurement, there are things that go along with that. Some of the benefits, you know, the looser coupling. I think a lot of these things, if you dig into unit testing literature, they talk a lot about how when you start out with testing, you know, you'll start thinking of things in such a way where you can break them up. You could say you've got a really decoupled design and your stuff's really testable, but a lot of times, if you haven't written tests, then you'll find out once you try to write tests that it's not actually too testable, and that you like have to bend over backwards to like get some sort of test around it. Some people talk about automated set of requirements. Sometimes that's easy to achieve. Sometimes it makes sense, but that's one of the benefits. Is you know, people have talked about how they looked at their unit tests and it says what the application should be doing, so they could say, hey, here's the list of requirements for our app, and somebody new to the project could come in and be like, oh, this is what this is supposed to do. It's actually easier to read the unit tests and understand what the application is trying to do because of how they were written. So, and the biggest thing in my mind is unit tests allow you to fearlessly refactor. And some people think, okay, you just code long enough until you get the application like correct, right? But that doesn't account for the fact that things constantly need to change, right? Software is like the source code is a living thing. It needs to be changing to like stay up to date and to adopt new technologies, and you know, there's a lot of reasons, right? But if you start thinking of it as a living thing, then you start thinking, well, maybe we aren't just like trying to get that last thing, and we should make it so it's easier to change our code without breaking all the things that we did before. And that's really, I think, the goal of unit testing. So the way it fits into the Agile process, and I modified this a little bit because we're sort of structuring, actually it's based on the continuous delivery stuff that I went to. They talk about continuous integration really being the part where it runs like unit tests and maybe some integration tests, but then continuous delivery does all your acceptance and system UI. So that's kind of like, I think everybody's kind of familiar with the Team City structure that we have, and that could change, but it's pretty close to, you know, what we got. So does anybody not know what red-green refactor is? Okay, it's up there. You can read it. So it's pretty simple, but there's a reason that it's like this. Like the actual like steps that you take, there's a reason that you do it this way. It has to do a little bit with like knowing that your test does what you think it should. So, because you can write some code and say, this is testing this thing, and if it passes, then you think, it's really getting rid of like the false positives and negatives, right? You want to know that when you've coded something that it works. So it's a really simple couple of steps where you start out, you write a failing test, so it's failing. You write the code that you think fixes that test. Once you write that code, you've asserted that with that code change that you made is what made that test pass. So if you ever change that code again and it isn't green, then you know you've broken something, right? And then the final thing is refactoring, because once you have the test in place, it puts you in a position where you can take everything underneath that isn't affected by the test and rearrange it to restructure it. So maybe you want to move the software in a new direction, and you know, sort of it helps you to you know, in a quality way embrace change. So unit tests are really important, and some people think that, oh well, this is your test stuff, so if that stuff like goes down or is failing, then that's okay, because it's just like, that's the crap test code, that doesn't get shipped out. But I mean, one of the things Ken Beck says, right, and he does, he's the XP guy, he's the sort of the father, right, is he says it's really cool when you can take all of your application code and throw it away, and you can rebuild it in, like, from scratch, and have like all these like sort of like pinpoints that say, you know, you should be able to come up with software that does exactly the same thing, right? So, and from that aspect, you know, your tests are really important, and the more work you put into your tests to make sure that they help you in being able to refactor without breaking things is really important. Another thing is Michael Feather's quote, "Without unit tests, your code is legacy." And I've heard that a lot. Like, sometimes people will repurpose like the word legacy to mean that it's code that doesn't have tests around it. But that's kind of like a positive connotation where it's like, dude, you should be writing tests that have, or you should be writing code that has tests around it, because if you're not, then you're just like you can't change that code later, even if it's working right now. There's no way for you to do that. So
it's funny when you say those things. It sounds like you're just talking about interfaces.
Well,
people say the same thing about interfaces, right? Like all programmed interfaces. If you don't use interfaces, then not refactorable. But how is that? How is testing and testing?
Well, making an interface doesn't mean your code works. Your test passing means your code works. And if it doesn't mean that, then that means that your tests are your tool. So if they suck, then that doesn't help anybody. It doesn't help you, So obviously you're going to put some effort into good, but just having the concept of an interface doesn't tell you whether your code's working. Doesn't let you refactor. In fact, some people have this idea that oh, I'll put an interface on it, more testable, it's going to make it more robust and easy to change in the future, but you're just adding a layer of delegation. You're not really making it so that's easier to change. You change that interface or something, and that's just 3 more places you need to change, You change one of those things, it's still not going to work, But how do you know it doesn't work, Well, hopefully your tests tell you it doesn't work, right? So here's some code smells, and some of these are they don't seem intuitive, but I think once we go through, they'll start to make a lot more sense. So tries to test too many things. It seems natural, oh, I'm already in there, I'm just going to add this other thing in there. So you've seen those tests, right? I'll show you one later. Contains too many dependencies, right? So, and we'll get into some of the reasons why that's a bad thing. Trying to keep your tests dry using inheritance, bloated test cases. So a lot of fancy I'm going to use all the object-oriented features to make my tests real clever and funny and cool. But your tests, you want them to be really easy to diagnose. They should tell you. It should just be an indicator that says that's red, something's wrong. You know exactly without even debugging what's wrong. So hard to read, not obvious what's tested. That's not helpful to you or anybody else, because you want somebody else to be able to read that. You want yourself to remember, right? So. And especially if they're failing right now, they're not very useful tests, right? So if your application is working but you've got failing tests, then your tests, delete them. You know what I mean? It's oh, no, don't delete those tests. It's they're good. They're just they don't actually test anything right now, So here is, oh, shoot. Did I mess something up? I did. I hid the presentation. Sorry, guys. All right, so here's a test that I found. And what this guy does is, it's being ignored right now, for one. And it looks like it does a lot of stuff at the top. And then we get into here. It does some stuff. And then this is where we start to get really good, where at some point we do, oh, finally, we found the assert. It's at the bottom for each. For all the gift offerings, assert is false. For altered list payment methods, response any. And oh wait, actually there's more asserts. So we got a for each that does a bunch of asserts on here. This is probably not what you should aspire towards when writing your tests. You want to be able to jump in, see what's wrong, and jump back out. So integration tests. Not everything should be unit tests. Integration tests. I have a lot of the same sort of philosophy with writing integration tests. They should share a lot of the same qualities, but some places where they differentiate, where the dependencies can't be isolated, like with your DB and IO, right? So reading a file or some shared resource or singleton service thing, right? They are better at actual tests, trying to test something, but they could fail from side effects, and you want your tests to only fail when you did something to actually break your code, to get more back in line with the idea of them being measurements, right? A lot of times they're slower, and if you look at the pyramid of the testing pyramid, usually they say try to get as much as you can in the unit test area, then integration test, and then UI. And it's hard to really go into why that's important. But so many projects that end up having a heavier top end are ones that topple over because I don't know. I can't get into why. Maybe somebody else can chime in there.
They're slower running, fragile, and more
more expensive.
They're harder to debug. There's, you know, they have a lot of dependencies, and there's just yeah. Anyway,
How does that beat that?
yeah. Yeah. So Dansky was just saying the feedback loop is really important. Like he was saying, the B2B store, we've got about 2,500 tests that run within a matter of seconds every time we click save on a file. And so that's awesome, you know, to be able to make a change and then see immediately, like, bloop, up, these things broke. And so, you know, careful. Has your idea of this changed? You need to go in and change the test and then change the code. Anyway, so another thing is, like, a lot of times integration tests are mistaken for unit tests, but that's kind of like novice stuff. We've got all pros in this room, so.
Well, I have a question about it. So behavior-driven development, I thought that focused on integration, kind of like the and that thing. Does this basically say that you shouldn't be prioritizing behavior-driven development?
I don't think BDD, like, there's people that will say, you know, BDD, okay, generally is going to be more integration tests. BDD is not specific to integration tests. In fact, you know, the guy that came up with BDD talks about how he was having such a hard time describing TDD that he ended up making BDD because, like it's like, no, you start from, like, the top down, and it's sort of like BDD technically is like a more it's got more rules than TDD, right? So it's not just like, a lot of people do unit testing, then they'll start at the lowest possible layer and, like, start testing their way up and building a stack, whereas he's like, no, you start with requirements, you, like, you know, mock everything out or test stub, whatever, and then you drill down in your layers. Once you've proved out that, like, some sort of, but it's like it's more focused on, like, you know, proving out some sort of user behavior that, like, we're building the right thing, not that we're doing it correctly. Does that make sense? So
it still sounds like more focused on integration tests and behavior.
well, sure, except, I mean, honestly, you could write a lot of, you know, how they did it early on is they would mock out those layers, like, just below the surface. Those were unit tests. And you would do all your BDD stuff with unit tests. I mean, it's not, there's no, like, constraint that says, no, dude, these guys have to. Now, a lot of people, actually, if you read the XUnit patterns book, he talks about, he builds out his unit test with layers, right? And then eventually he pulls out the mocks and the test doubles, and he has those just be integration tests, and they run the same tests, right? So there's not really, like, a hard and fast rule that, like, you have to have these one way and, you know, these things another. Anyway, I just want to give an example of an integration test and just show, like, sort of one thing that you know, that we'll talk about some of the qualities of the unit test in a second. But this has, like, the transaction scope, and I know that on other teams it's done in sort of like a base class, but it's the same sort of concept where you want your tests to be able to, like, run and not, like, affect anything else. And this is one of the ways to do an integration test where you know, you're not stepping on each other's toes and you have to, like, maintain some sort of state. Anyway, so but these integration tests will look a lot like the unit tests that I personally write. And there's a little bit more. They do a little more. You know, they touch some shared resources, but a lot of the same qualities, because even if my integration test fails, I want to be able to understand what thing failed or, like, why it failed, right? It's because of some code change that I did. So here are the qualities of good unit tests. So they're organized, dry. Everybody know what dry is? Don't repeat yourself. Descriptive, or otherwise known as DAMP by Mark Seaman. He does, I think, the advanced unit test course in Pluralsight. Independent, repeatable, small, one logical assert, diffuse dependencies, and fast. Remember all those. No, I'll go through them real quick. So, so organized. Everybody knows, I think everybody does. If you're not, there's arrange, act, assert, or given, when, then patterns for basically ways of organizing your tests, right, into, like, the three logical parts. And it's pretty simple. You know, it's kind of boring. Set up your test, do the test, assert, right? Sounds pretty simple, right? Dry. So, you know, don't repeat yourself. But in order to do that, you don't want to like pull things out into weird places so that your tests are hard to debug. So there's patterns that people will use, like when you're doing your setup for all your tests, you use like a builder, right? Or like a Fluent sort of model building kind of thing. You set up your test structure, and builder's real simple. The rule that I've heard from like Martin Fowler refactoring is, you duplicate code twice, or sorry, once, so there's a duplicate. That's fine, but you find like 3 identical pieces of code, and you should refactor that, right? And so here's an example of the test data builder. It's real simple. You just return the object that you're building. So like you return this. You can do this with, there could be, what's the thing? The static extension methods, right? C#. So here I've got the test. You can see it says card service has gift card, has existing reload, and just keep returning self to like build up this service that we're testing, right? And then in here, the builder, download these 2 sections of code. They're different. Returns this. So damp, and this is like sort of feels like the opposite of dry. So it's like kind of like the yin and yang of testing. But basically, it's like don't be afraid to be too descriptive. You want to be able to read these later. These later. Did I misspeak? So here's one thing is, you notice I've got underscores in the name. Some people don't like that, and I would suggest, like, whatever your team convention is, it's nice to all, to get some predictability on your team, like, with what you expect to see in your code. So if you guys don't do that, and a lot of people do, like, given when then, and then they have, like, just Pascal case, cool, whatever. Don't fret too much on some of the naming of your test stuff. Because it's like one of the easiest things to change later. Hopefully you don't have any dependencies on those test classes, right? Conventions like test is generally in the name. That's not a bad idea, It's sort of like lets you know that, that's like one convention that's like pretty easy to say, yeah, sure, do that. Test classes that don't like have tests in the name are like, what? What is that doing in here? That must be like a utility crap thing. Delete it, So tests should be independent and repeatable. So meaning that, like, you notice how we did that transaction scope and then we didn't complete the scope, meaning that it wouldn't actually commit any changes to the database. That's so that you could have all those tests, you can run them in parallel if you wanted to. They don't step on each other's toes. They don't. You don't have to run them in a certain order for them to fail. You want your tests to be independent of each other, so that when that thing, as a meter, like, it goes red, that tells you that something broke and it's because of something you changed, and not because it just happened to run in the wrong order. Does that make sense? So, and with that, some things where people get caught up is like people will like use like time, and it's not like you shouldn't use time in your test, but your test shouldn't pass depending upon what time it is. Okay? It seems silly, but like there's tests that have been written like that. So no use of random. Random seems really cool, like, oh man, just put some random in there and then we'll get like better test coverage. But that's like thinking in terms of like, this is something that like when it fails, you're gonna like be able to catch that bug. No, you want things only to break when you break them, right? And it seems like sort of, anyway, whatever. Sure. Small, fast, always a good thing. You want them to be like, dude, nobody wants when something breaks to have to like jump in there and like spend 8 days trying to figure out what the test is doing, right? So take a second, look at this example unit test, small and fast. Notice I've got it in the arrange act assert or given when then. But really fast, right? Fractions of a second. You shouldn't have long running tests. And it's like the things you can achieve when you have fast running tests, the places you can use that is just like what Dansky was saying on the B2B team. We've got our tests that run in a matter of seconds as we click save. If they ran in 5 minutes, we wouldn't be able to go save and then like wait for 5 minutes for like the tests to run. That's, there's things you can achieve when you like aspire to have, your tests running fast. One logical assert. This doesn't mean that there's only one line that says assert, but most of the time it does. The time it doesn't is when you're doing sort of like an object comparison. And some people will get around that by doing like they'll like override what the equality is for it, you know, so that like they can do just like R equal, and it'll use your custom logic that says compares the objects to say what equal means. Some people will there's actually where you can specify what equal means. Some people will do it, you know, where they just inline have like a few parameters that they you know, will check like these parameters. That's a slippery slope because, you know, when you add and remove parameters, you want to sort of like see that, but it's up for debate. I mean, that's a hard area. Like, there's a lot of bloat with some of that like equality code. Anyway, auto fixture, I wanted to call that out as a tool that does this likeness kind of thing. It's kind of like automapper, but for tests. It can like take two objects and say, based on the properties they have, do they match up? And then it'll fail when they don't. So that's kind of cool. What? Sorry, 8 people talking. Fluid assertions, what? So this, yeah, you'd have to look it up. Auto fixture, remember that. If you're curious, look it up. It's pretty cool. It's called the like. So look up like. I don't know. He has really terrible naming for his stuff, but it's a cool thing. The state versus behavioral. This is like a really interesting one. And if you look up like traditional TDD versus mockist, there's like sort of this like big on-running debate about like, you know, whether like being a mockist is cool. And I would say it's more about whether your tests are behavioral versus you know, state tests. So a state is basically like, you know, I have an object, it goes through some code path, it's like a black box to me. I come back, I check the state is what I expect it to be, right? Behavioral is like, it went through this method and this other method got called. Now sometimes that's useful as you're sort of like in the flow of developing something and you want to like test a cache and make sure that that cache was actually called the subsequent times. But you don't want to keep those as like your unit tests. I mean, that's sort of like a flow testing. I think flow testing is cool. You know, using it as sort of, instead of console app, you use like your tests to be able to do, you know. But those aren't like good for refactoring because what they do is they tie you to you know, they tie you to an implementation. They say this has to be called. You could be resolving that requirement in a different way, and it doesn't matter. So like your test would fail just because it doesn't have that line of code in it, even though your code still works. You know, and so that's why it's kind of a negative thing. But you know, another place where you would do it is if it's the only way to reproduce a bug. So strive for state. Behavioral is okay. No, whatever. Diffuse dependencies. So inject or remove static dependencies. And the remove static dependencies is something I've talked about with some people with just doing some composition rework where instead of like, well, I'll talk about that in a sec. Use a mocking framework or other test double. So that's how you get like, you know, the file system or the database out of the way to be able to do your tests. You just have to do that. So warning about mocks though. So how many people are not familiar with mocks? Okay, cool. That's great. I hope so, right? So the thing about mocks that you have to keep in mind is that they're fake. They're not real. And so like you write a test that just says like that you're doing what the mock behavior you coded was. It's like those are not good tests. Like they're not helpful. They don't help you in any way. And so you have to be careful about when you use mocks and knowing what you're using them for. You're using a mock to get a dependency out of the way so you can focus on your test, you know. And that should be like the big reason to use mocks. They do encourage like behavioral testing because you could be like, oh, I just wrap that thing in an interface and I can just say what it does and then I can do my tests and like, no, it's kind of a mess, really. It doesn't help you refactor is the biggest thing. So if you're not just trying to get something out of the way, like you really should have some content in your tests that like tests that it's doing a certain thing, right? So mockless testing is this sort of idea that I've like poked around. Now, everybody does it, but it's something that we've been doing in the B2B team, and I was going to give an example tomorrow during our demo of how we did it. And the basic concept is that instead of like the traditional, you put in a reader, you put in like a database access dependency with an interface, or you know, you just inject that thing that like read something or get something, store something, you put in the thing you're going to work with instead, right? So instead of the configurator, you get the config, right? That's what you put in the constructor, right? Another thing is having like, instead of having like object env, the code smell, you put things onto the model themselves to be able to, like they can manage their own data. That's another thing where you do that, it's not on this thing that has all these dependencies anymore. You only need to new up that model and then work with the data to test that your requirements are true, right? So that's the only dependency you have. It's pretty nice. And collaborators are like an interesting subject because a lot of people have been like told, or there's a lot of like, there's this idea that your unit tests are only a unit test if they don't have other collaborators in the test. And you know, Kent Beck doesn't agree with that, right? So the unit test is really just the smallest testable part of an application. So if that includes collaborators, that's okay. But the idea is that you want your unit test to very specifically solo out a piece of your application so that when it's not working anymore, that thing goes red, right? And don't forget to refactor. This is probably the biggest reason that you use unit tests. I mean, sometimes we'll like create code, we'll write some tests, and we're done, sign off. But you know, you can actually find a lot of benefit from going through, having your tests there, and then deleting some code and you know, typing it again, you know, or just seeing like, you know, okay, we did this really fast, and the unit testing helped with the flow so that we had like, you know, a nice response mechanism, kept us going. But now this code that's there, like, we don't actually want to like keep that, and we happen to know that we're going to need to do something else in the future. Let's restructure this around. Dude, like, my code's been wildly different from refactoring after having unit tests a lot of times, and I feel like it's one of those things that a lot of times gets forgotten, but it's good stuff. So yeah, do it and stuff. Okay, so here's some code smells. And if you haven't read, like, there's Martin Fowler refactoring. He goes over a lot of these code smells, and I think it's where that term was introduced, even though he didn't make that term. Yeah, so refactoring should be a part of our organization. You should be confident in being able to change any part of the code knowing that we're safe because of our tests, right? And so these are things to refactor away from. So refactoring legacy code. The platform team is actually reading a book, Michael Feathers, about working in legacy code. And so basically, from a high level, my strategy is generally you create some sort of integration test around that stuff. You build a new thing that's unit tested. You replace that thing, and make sure your integration test still works. It sounds easy. It's actually sometimes really hard, and like hard enough that you're like, I don't really want to do it. But but if you wanted, like, you can sort of like develop habits where it's like, you know, it is like, it could be a best practice for you to like be able to, if you want to like not have the types of failures, you know, it's a safe way to do it. Martin Fowler refactoring, it's a really good book. It's Java, but whatever. Get over it. Any questions? Sorry, it took a little bit longer than I thought, but some of the stuff, some of the code examples and everything in there, you know, they definitely have some like my preference, right, in writing. There's different styles. I think the most important thing is on your team, you know, you can all like sort of agree on a structure for that, so it's easy for you to jump in and recode. But beyond that, I mean, no matter what team you're on, I think all of our tests should share these types of qualities, because when they do, I mean, honestly, it doesn't matter like how many, in my mind, how many of these tests you have. If they're written this way, they're going to be helpful. They're going to be useful, and yeah, like right now our test coverage is pretty abysmal, right? But for a lot of our new stuff, it's great, and a lot of us are already doing unit testing, and so really I'm hoping that most of this is just sort of like refresher for everybody that's sort of already done their due diligence, like going through and saying like, what is the best way to do automated testing, because you know you feel accountable for your features and you want them to be good. Yeah.
It felt like you on the unit testing, you mentioned integration testing, you need that on the
Right.
because integration tests often want them to fail in the UI. You want them to fail, you know, in the database.
Yeah.
Because that's the integration.
Right.
So, okay.
Well, the difference is that when you get higher up in the chain, like in the pyramid, you sort of anticipate, like, there's more of like a lenience with failure. Like there's failures from other causes. Like your unit tests are different in that they shouldn't have, you should be able to run them in isolation. The only thing that should break those is when you do a code change that does break them, and like you didn't anticipate that, right? Yeah, that's definitely a dependency. So that's like a file I/O dependency, and if you have that and your tests fail because there's something screwed up in your config, then your test, like, that sucks, right? That does not suck. In my mind, that sucks. Like, I want to be able to take those tests, run them, and know they're just going to work. Yeah. Right. It just depends. Honestly, like, when is testing, when is it enough, right? Like, how do you know when you've done enough? Um, in my mind, it really comes down to QA. Like, QA should be able to tell you the confidence that we are, like, doing this effectively. It's a team effort, you know what I mean? But, you know, QA will have a sense of, like, whether we can ship something based on our automated tests, and they're responsible for that, really, when it comes down to it, right? They're like, their butts on the line that, like, you know, this thing goes out there without bugs. And so what that means is, if you feel confident that the thing that you're testing completely with unit tests, like, covers all the risks that have been outlined as the highest priority to cover for, like, the test strategy, then that should be okay. But a lot of times, you know, that's not the case a lot of times. You're going to need some sort of integration test. You're going to need you know, tests for your user interface. But when you do that, if you know that you can cover that at a lower level, then it seems silly not to do that, right? To pull that into a place where you can more reliably, like, use that to see if something's broken. If you depend on it from, like, one of those other layers where you expect things to maybe fail for reasons that don't have to do with code changes, or, you know, or that are going to be harder to debug because of it, you have to jump into the debugger and go through, then, you know, that really is like, it's a productivity thing. It slows you down. So, and maybe that's actually the reason I was looking for when I was talking about sort of the test pyramid. I generally have a rule of, like, I do, like, happy path integration tests for a lot of that stuff, where I need to, like, sort of reach deep dive and actually have it hit the database. You know, because you start doing the permutations of different scenarios and that kind of thing, and that gets expensive. And it becomes, that's when, like, your test stuff, in my mind, like, becomes more work than it's worth. Like, you'll spend a lot more time working on your test stuff, not getting the, like, it doesn't have the ROI, you know what I mean? So. No, I mean, I would say everything that you can unit test, you should unit test. And for everything else to, like, meet your quality, like, coverage, right, based on working with QA and saying where your risks are and where you need to cover, that's where you say, we put integration tests here, right? Smoke test UI stuff, just a few, like, there, you know, just to cover the things that can't be covered any other way. But if you find an opportunity to, like, refactor that into being unit tests, do it. You know, I mean, that.
It feels like there's a lot of
It is a challenge, and that's why, like, unit testing is hard. It's hard to figure out how you can honestly, it's an art, I think. It's like, how can you restructure this so that you can cover this risk with unit tests. The easiest no-thinking way is to say, get Selenium, do all your button clicks, record them, and then you're good. But that's like a failure scenario, you know. So you start to drill down. Okay, well then what's going to be my automated test strategy that will allow me to do the least amount of work possible and keep me really productive, so I can find the issue that's at hand, right? And if you have a code base that's really well unit tested, and then you do see failures in a certain area, then it actually helps because, you know, like you've got this integration test, it's failing, you know the area, you can kind of say, based on the tests that I have, is there something that I'm missing here? It's really easy to identify, and you're like, oh yeah. Even with integration tests, it becomes easier to say, okay, here's where I'm missing something that I can cover in a unit test manner, right?
You said like unit tests, so that you don't have to write integration tests. So you can
I'm saying that your goal should be to write unit tests, period. Like when you're developing, TDD is about when you write production code, you're writing tests along with it. And if you're in that flow and you're doing that and you're making your tests so that it's easier to refactor, the test coverage strategy is a separate thing, right? It's like how do you manage the risk based on where you're at? And even though it sort of fits into it, it is a different thing because your unit test should be something that allow you to refactor and don't have like external dependencies. And some people can get really close with integration tests, right? And to the extent where you know that line starts to blur. But you know, there's lots of opportunities to be able to turn those into unit tests. It just makes them a little more resilient, and you know.
Can you explain a little more about the unit tests? You're talking about within a test doing communication. You're talking about
Yes.
testing
Too many asserts in a test.
within it.
So like you have a test, like your test, every unit should be like a unit measure in your application, right? So when that fails, it's because one unit of your application's functionality stopped working, right? You did a code change that like broke a bunch of stuff. You should see each one of those like pop up. But what you shouldn't have is like a test that just like doesn't want to pass, and every time you've like, because you've got like a billion asserts. One thing that I have in the slides but I didn't mention is like you don't test your like setup. You know, you want it when that test fails, it fails for one reason. You don't test that like your setup was successful. You want to know that your setup was successful. Make that another test. So it should fail for like one reason, right? Otherwise, it's not as helpful. You don't want to spend a lot of time thinking about your tests after you've written them. You know, you just want them to help you. And if you do a lot of asserts at the time, it seems really intuitive, like, oh, check this, check that, check this, that's cool. But then like when that test fails, it really doesn't tell you much. It just says somewhere in this glob of asserts, you've got something that's screwed up. You know how you fix that? You go through every single thing. You start like guessing where you're going to punch in breakpoints, and then saying, okay, shoot, it threw an error over here. I got to, you know, walk through again. And you don't have to do that. I mean, dude, so much of our development lives are around debugging. Like, why would you want to make tests that force you to debug longer? Right?
What do you want to go improve?
Show up to this meeting. You know, there's a lot of, you know, there's a lot of literature on TDD. There's books on TDD. I think probably my favorite is, well, a lot of people talk about Kent Beck's XP books being like really, really awesome. That's sort of like the beginning of like getting into that stuff. XP had a lot of like, you know, software process like things like mandating like refactoring TDD, all these things. TDD was one of those things, right? Kent Beck stuff, Martin Fowler's, a lot of these like agile guys have a lot of awesome literature on design patterns and how that fits in with testing. A good book is the X-Unit Patterns, which we have a copy of. But you know, I really think that like something like I really enjoy reading Martin Fowler stuff. Everything I read from him sort of is like feels really intuitive to me. It's like, oh, that just makes sense. Like he'll have these like short blurbs. His book on refactoring is really good because he actually walks through and he says, here's some example junk code. Here's how you make it not suck anymore. And it's in Java, but I mean it's very close to C#, right? And he talks about how here's my process. Here's this refactor method that I have, and I'll call it this, you know, and it takes care of this code smell. So I write a test, I pull this code out into here, da da da. So say this, you know, requirement changes. Here, I go change the test, it's failing. I go and change the production code. I've asserted that the change I made to the code, to the test, was fixed by my code change in production. And so that sort of flow sort of like takes the question marks out of your mind about whether you can do what's called characterization tests, where you like write the tests after you've written the code, right? Because it's like, hey man, I got the test. But if you're going to do that, make sure to like go and comment out the code to make sure that it actually fails, right? When when it runs, so you know it's actually protecting you, right? But even then, that's not necessarily like the best way to do that because you know maybe it's still not like covering that. It's like I said, it's an art. Like it's hard to like say there's the right answer there, but you know. Cool. All right, dudes. Yeah.
Is there like an expectation about?
Yeah, I think all teams should have like an expectation of testing. Most of the hiring that we did, there was like a real big emphasis on like bringing people in that knew a little bit about testing, like that you know were strong, agile, like testing developers. So a lot of this stuff I wouldn't think would be a surprise to people. Maybe just sort of if you had questions about one thing or another, bring more of an alignment in. But we should. Since I've been here, we've gotten the continuous integration stuff up, with Nick getting the Team City going. We've had tests running in there. All the new stuff that we've been doing has had unit tests around it. Now, whether those are maintainable or not, it's like up to the developers making those tests. And hopefully this, if you're doing some of these, like violating some of these things, you can like change that because, and for reasons that we've talked about. But yeah, everybody should be doing unit tests. I mean, does anybody's team not do unit testing? Like, yeah, all right. Well, you know what's funny? You know what's funny about that is like, some people are like, unit testing. Oh yeah. We don't do it. It's dumb that we don't do it, right? And it's like, but somebody needs to give me time to do that. And it's like, no, dude, you just start doing it. It's you. Like, do it. Like. Stop not unit testing and just do it. It's like hard, but it's up to you. Like honestly, sometimes you're blocked by not having the infrastructure in place. We've got Team City. It's easy to pull up projects for test stuff. There's no reason that you can't be unit testing. And I happen to know that your team does unit testing. I know that Earl's been doing unit testing.
My team does. No, I'm saying you asked a question. I write integration.
Oh. Come on. Come on.
No, I don't.
Yeah. Yeah, but I'm like very against using code coverage metrics like as part of a. I mean, unless you're already there. Like for one, our platform's just not there. For two, I don't want to encourage people gaming the metrics in order to have, because you can just make something that games it. I don't like that. I like to have really good tests, and sometimes there's good reasons not to unit test a certain section, right, of code, and so it won't help your metric. You can customize the metric, but the code coverage tool is a tool, and its goal is to help you identify things you didn't think of, right? Oh, there's a path I didn't test. Is that important? That's what that should do. Not oh, shoot, 95%. Oh, there we go. Call that method. We're good. We're just write a test, calls the method, no assert, we're good. You know, like not null. Like, something stupid, right? That's not helpful, right? So you have to like want to have the test.
You ever go back to the test?
Dude, every piece of code I've written like 2 weeks ago is terrible. You know what I mean? Like, you like go through the code, you're constantly improving, hopefully. And so you're gonna look back and be like, I could have done that better. So you hope we're in a toilet.
Yeah.
Cool. All right. Cool, dudes.